Hello, Earthlings. Welcome to Data Science for Everyone. My name is Andrea Jones-Rooy, and for many years, I taught a course, 11 semesters. Was it 12? Doesn't matter. 11 to 12 semesters of a course called Data Science for Everyone, which was the foundational intro course for the data science major and minor at the NYU Center for Data Science. Over the years, I have had many co-instructors, and they have played a wonderful role in developing this material. So any material that you see in this online course that you think, wow, that's awesome, it definitely comes from Professor Arthur Sperling, Professor Sarah Sugars, Professor George Wood, and or Professor Marco Marucci. If you see anything in these videos that you say, that's terrible, wrong, stupid, insulting, blame me. All right, but I'll be presenting it all, and I'm super excited that you are here. So the way we're going to do this is the highlights of the course that we taught for many, many years. There is an accompanying book that I will link in the comments. And ideally, you should be able to watch these videos in roughly any order, though there will be some exceptions where you'll see things labeled like programming 1, programming 2. I recommend you watch programming 1 first, but who am I to tell you how to live your life? Let me also say, I taught this course for many years and I am no longer at NYU, but I want to share what I think is a really important series of messages and lessons to folks who maybe would not otherwise have access to an undergraduate education in data science. So if you are a current student at NYU, I highly recommend you take the course. But if you're not, I hope you enjoy this highlights version of it. All right. So the whole point of this course, Data Science for Everyone, is based on the idea that literally everyone can and should be a data scientist. More specifically, we believe that data science is an essential part of being a global citizen. That's right, we're using words like global citizen in this course. I believe that all students of all ages, of all backgrounds, can and should learn to think like data scientists, and that data science is fun. Part of the reason that I'm taking the time to do these videos rather than move on with my life from my professor days is that I really feel grateful that I had the opportunity to learn data science. I stumbled into it in my own life. I'll talk about that elsewhere one day. But I feel really grateful to have gotten access to these tools. And I don't need to tell you that data science is all around us everywhere and is pretty much a prerequisite for many industries and many types of jobs. And I feel like it's really important, just like regular literacy for words. I think that data literacy is essential. So I don't need to keep talking about that because you're here because you probably agree. So a hearty welcome. As I said, this series of videos is based on the course. And over the course of developing the undergraduate curriculum and developing the course Data Science for Everyone, I believe we started it in winter 2019 and taught every semester from that moment, including a series of summer semesters, including through the pandemic, which was a mix of remote and in-person and hybrid and rotating and all kinds of wild things. So we've taught this course in every which way. Over the period of time that we were working on it, my colleague Arthur Sperling and I, who is the co-instructor who has taught this course most along with me, and I developed a series of notes from our lectures. So you can think of this as a textbook accompaniment to our lectures. You can think of this as our lecture notes. So the full course is basically available to you free online in the format of this book. I'll post a link, as I said, in the notes so that you can read it and access it anytime you want. And these are video accompaniments to go with it. So yeah, so there you go. The other thing I want to say is that, as you can see, we've adapted our text and, frankly, this course from a course called Data 8, which is at UC Berkeley. And they have an online textbook called Inferential Thinking. We have based our work on their first edition. So the latest they updated their first edition was in 2017. So we started building from that version, from the 2017 version. They have a more recent version out. So we have forked off from around that time when we started developing this course. I kicked off in 2018, anticipating 2019. Anyway, generally speaking, the material in the videos is mostly from our course and is different from what was taught at Data 8. In the occasions where we do pull some of the examples from Data 8 because we think they're really fantastic and can't really make our point without it, I have included this Data 8 image. And in the text, we also clarify which pieces are from Data 8. So our thanks to our colleagues over at UC Berkeley for developing such a fantastic course. And you could read more details about what's different in our course versus their course. All right, so this video, what is data science? Yay! The good news about data science is it's brand new in the scheme of sciences, and there is no fixed definition for you to go out there and measure. The bad news is that when you go out in the world and talk to people about data science, or you say, I'm a data scientist, they may assume you are anything from someone who knows how to work an Excel spreadsheet to someone who's building robots and chat GPT generative AI. So there's a wide array of things that might count as data science. Many times my students are surprised to find some of the things that we end up talking about in data science. We talk about inference and ethics, and it ends up being quite philosophical at times. And of course, there's programming and stats like many people think there is. So, okay, so what is data science? For our purposes, here's how we're going to talk about it. We are going to talk about data science as better understanding the world or universe through scientific methods and data. Now, you might be arguing that this is specifically what we're doing with science generally, and broadly speaking, it is, though there's a slight difference or a slight focus on manipulating the massive data sets that are out there in the world in interesting and new ways. But generally speaking, if you say, wow, Andrea, you can call me Andrea now. You don't have to call me Professor Jones-Rooy, but you can. This sure sounds a lot like science. Fine. I'm fine with it. So what are we going to do in data science? Well, we're going to explore data. We're going to look at data sets and see if we can identify patterns and trends. Are things going up? Are things going down? Are things getting better? Are they getting worse? And so on. As we go in this course, we'll talk about topics like measurement, which is one of my favorites, which is how we turn the world from the things we see in the world into the numbers, symbols, letters that are in our tables of data. We're going to talk about why data is biased. That's very important to remember that data and capital T truth are not the same thing. We'll talk a little bit about visualization, not a ton in this course. There's a lot of great resources out there, but we'll talk about it a bit. And descriptive statistics, which you probably remember or use in your everyday life, mean, median, mode, and we'll talk standard deviation and all that stuff. So that's just using data to say what's happening in the world. The other thing we want to do with data science is we want to draw inferences. So we want to say, how reliable is a pattern? We might want to say, is there a relationship between X and Y? Does doing more of this cause this to go up? And how confident are we that that's the case? So we'll talk a little bit about experiments, not a ton. We'll talk about things like coefficients, significance. Those are terms maybe you remember from stats courses back in the day, or maybe not. And we'll definitely dig into this idea of causality. How do we say that one thing causes another? It's hard. That's the punchline on that one. And finally, and this is maybe where most industry is excited when it comes to data science, or maybe what many of you are thinking when you think of data science, which is suck in a whole bunch of data, take a look at it, and say, gosh, what does this tell me about what's going to happen tomorrow, 10 years from now, 100 years from now? Make predictions. So we want to make informed guesses about trends towards the future. So we'll use things that you may recognize, again, from statistics, regression, but we'll also move into machine learning techniques such as classification and others in order to say, okay, this is what we know happened in the past. What can this tell us about what's going to happen in the future? Or if I get new data, could you, computer, tell me whether this is an example of X or Y? So where does data science fit? This is one of the most important diagrams I'm ever going to show you, and one of the most important diagrams about data science. Forget it. It's one of the most important diagrams in the world. It was developed by Drew Conway. I would love to take credit for it, but I'm not that smart. Drew Conway is a living legend and a genius. You can read more about him and his work, and particularly his thoughtful description of this Venn diagram at drewconway.com. So data science, in our view, at the NYU Center for Data Science in this course, lives at the intersection of three areas of skills. So the first is hacking skills or programming. When my students come to Data Science for Everyone, they often think that programming is going to be maybe 90% of the work, if not all of it. And we picture Mr. Robot, fantastic show where he's typing like crazy and doing all kinds of wild things. Absolutely, programming is a key skill in data science, and programming and computational skills allow us to do a lot of interesting things with data and collect new kinds of data. But it's not the only piece. And in fact, one of the key things I want to highlight here right out of the gates is that all three of these circles are the same size: programming, math and statistics, and what I call What Drew tells us is substantive expertise. Math and stats, if you've taken a stats course, you can imagine how this fits in. We'll talk about this as we go. But the idea here is, hey, we have a sample of, say, what 100 people think about this, or what 200 people did after they saw a particular advertisement. Can we extrapolate from that sample to the broader population? How? What are the limits? Can we learn things about whether if we manipulate X, something's going to happen to Y? All that math and statistics that gets folded in as well. But I want to really emphasize this substantive expertise. This is the part of data science that we, to our detriment, don't think about enough. Substantive expertise. This can mean expertise in, say, history. Shout out to my amazing ability to do Google image searches. Psychology, medicine, business, right? Whatever other generic clip art you can think of. So often when we think about data science, we think, oh, I need to be a programmer. I need to have been born speaking in equations and be a math person. No, we absolutely need folks who are experts in areas that span all of human knowledge, curiosity, and interest. We need students and data scientists from the arts, from the social sciences. We need you from philosophy and music, and as I said, medicine. All these different things are going to help us figure out what sorts of questions to ask of our data. It's going to help us evaluate data. It's going to help us design more rigorous, more thoughtful, more useful, more innovative research studies. It's essential. And so it's just as important. Obviously, in this course, I can't teach you psychology or medicine, mainly because I don't know anything about either of those. My own substantive background is in political science. Happy to talk about that at length separately. Get in touch. But we are going to see as we go why it really matters to check in and say, what is it in the world that we're hoping to understand with our data? We've constantly got to check back in on that, and that's going to be key. So if you have substantive expertise, but maybe you don't feel you're a particularly strong programmer or stat or math person, maybe you've never written a line of code in your life, that's perfect. This course assumes you've never written a line of code in your life. If you have written some code, you can certainly skip or speed on through the programming lectures. But if you have substantive expertise or even substantive curiosity, you're a third of the way there. All right. And if you don't have that, some of my students come and they say, I'm amazing at math. I'm amazing at programming. I have no interest in taking courses outside of this field. I implore you, take courses outside of this field. Explore the world. That's going to actually help you make better discoveries with your data. Okay, enough of that. All right, so why have a special course in data science? And shout out to the folks at Data 8 in particular for clarifying this point. So why not have a lot of different courses? When I was your age, or whatever age you are, back in the simpler days of Y2K, Paris Hilton, the Bush administration. All right, second Bush, I'm not that old. Okay, we had different courses. Data science didn't exist as a field when I was in school, and I'll stop referencing how old I am, though I will have some references from television shows that will further give this away down the line. But we used to just have courses in different things. We'd have courses in statistics, we'd have courses in programming, we'd have courses in, say, research design or conducting interviews or surveys or something like that. Well, these days, it's the case that there are lots of different things coming together that have made it necessary or maybe more useful to bring all of these concepts into one course. In a way, you can think of this data science course as like a crappy programming course and a crappy stats course and a crappy research design course, in the sense that we're not going to go in depth on any of those three, but it's bringing the three together that offers a lot of power. I will say I'm not bitter, but I did have a student at the end of one semester say this was a terrible programming course. And I agree. It is a terrible programming course. We are bringing together three previously disparate fields and talking about how they can link together. Programming is going to be one tool that we're going to use to combine statistics with data and some critical thinking, but it's not the only one. Okay, so we now have more data out there in the world, on the internet, floating around. We all have access to way more data than ever before. I want you all to be able to, at the end of this course, or even partway through this course, say, I'm interested in poverty rates in this country. I'm interested in the spread of disease. I'm interested in climate change. I'm interested in what makes Taylor Swift songs so popular. You have access to that data. I want to empower you to roll up your sleeves and actually start working with the data that's out there. These are some of the many topics that are very easy to find data on, but certainly there are more. It's also the case, and this is going to make me sound super old, but computers are crazy powerful. computers are wildly powerful these days. They did not always used to be that powerful. And the fact that we can do all kinds of wild analyses and that you can do machine learning on your own computer, and we'll talk about how, is incredible. So get out there, and we're going to start to talk about how we can use this computing to do things like you see here. And finally, we're going to talk about this less in this course, but one thing that you'll see as you continue in data science is we can use data and computing to actually move from observation to running experiments that otherwise in the real world would not be possible. So we're going to talk about that in the form of simulations mostly. But if you've heard of A/B testing, that's another example. And there's a lot of really interesting research that we're able to do now because we're combining the data and computation. All right. Last couple of pieces I want to say about this, and a special shout out to my colleague and friend Arthur Sperling for the Einstein imagery. Data science is a science. It's right there in the name. And some of the reasons it's a science are, well, we want to evaluate the merits, say, of a hypothesis using evidence, which is our data. And we're going to use rigorous testing. We're going to use statistical and machine learning methods to do that. So that's pretty rigorous and scientific. We need to be very precise. One of my professors in graduate school, he was talking about game theory, but it's true for science generally. He would stand in the front of the room and he would say, "We are making a commitment to precision." And oh, my arm disappeared. We are making a commitment to precision. And we are. In science, we are committing to precision. We are being precise about the route that we are taking from the observation we had in the world. This went up to our conclusion. We better stop doing that. We want to talk about our confidence in our results. We talk about maybe confidence intervals. We talk about errors. We talk about statistical significance, dangerous word. We'll talk about that. And we'll do so generally in this course using statistics. We also, as scientists, are going to examine and create huge data sets. And we're going to do so using all kinds of new techniques and computational advances, et cetera. This course is less about collecting data, but this is certainly a big part of data science. Data science is also an art. This is something that not enough folks out there appreciate. Just a few ways that data science is an art. Well, we are going to spend a lot of time thinking about how researchers, if we're looking at a data set, one of the first things we want to ask is, how did the researchers collect this data? How did they turn this real world phenomenon that I'm interested in into the data set that sits before me? As I said, we won't be doing so much data collection, but all data out there in the world was collected by somebody. Even if it seemed highly automated, someone somewhere pressed a button to automate the collection of that data. Why did they do it that way? Is that the best way to capture that thing that we care about? So we want to actually translate. We want to think thoughtfully about whether this translation is really picking up the thing we care about or not. We also want to develop an intuition, and this is going to be based on principles. This isn't just, how I feel generally. This is my gut reaction and my instincts based on having trained myself to think very thoughtfully and carefully about what makes a good data set or what makes a good model. But there really is an intuition at the end of the day where we say, I think this study is really helping us tap into this thing, or I think this study misses the mark. Think of kind of critiquing our data sets. And a lot of science is about doing research, presenting that research to other scientists, and having them say, I don't think so. Go back to the drawing board. And it's really, there's as much intuition as there is rigor. And you'll see. All right. Suspense. And we really want to, as we go, think creatively and think simply about designing our research projects, about deciding what to measure and how to measure it, about deciding what to include in our models. If we are trying to make a prediction using machine learning, in the cases that we'll be doing in this course, we're going to say, okay, computer, pay attention to these 4 things, and then tell me what's going to happen to this thing. Why those 4 things? Well, because we decided those were what were important to look at. So we'll see lots of examples of that. Also throwing this out there, my understanding is many students come to college to get a job, and or many of you may be watching this because you hope to use this in your job. So I'm obviously very biased, but many people agree with me, and I have hand selected some examples that do so extremely well. What is it like to have the best job in America right now? Well, it turns out being a data scientist is one of the best jobs in America, and I'll link to the article in the show notes. So we get high salaries, a huge role in influencing. If anything, data scientists are currently getting too much credit, and we have a little bit of an overly inflated idea of what data and data science can and cannot do. Part of the reason I'm doing this course is because it's important to me to clarify what we can do with data and what the limitations are. Even with all the generative AI and all of that, data is not perfect, science is not perfect, and that's kind of actually the point of both of those things, is being aware of the fact that we're not perfect. All right. More top jobs. This may go away. We might be in a little bit of a data science bubble. If you're finding this course as the bubble is bursting, my apologies. So if you want to join us for the course, here are some of the, I think, awesome things you'll learn. So we're going to revisit the scientific method. I realize you may be tempted to skip that one if you are anything like I was many years ago, where I thought, wow, snooze fest. The scientific method is actually going to be, while feeling terribly analog, a very, very helpful way that we're going to go about wrangling data and figuring out what analyses to conduct. We'll talk about the quality of a data set. Just like there's information and misinformation out there, there is great data and terrible data out there, and it's really important that we can make a distinction between the two. We will talk through how to import and organize data using Python. We'll do a little bit of descriptive statistics and visualizations in Python. We're going to talk about things related to data science in terms of ethics, data privacy, basic stats, evaluating the relationship between two things we care about. We'll talk about machine learning. We will, over the course of this, emphasize how to go about conducting a data science research project from start to finish. As I go, I will encourage you to say, by the way, at this stage, if you're interested in practicing, go find a data set. At this stage, it's okay, even if it's not a great data set. Go find a data set and try these things out. Ask a few questions. Evaluate some of the answers. Share them with me. I'd love to see what you come up to. And we'll also talk about how to evaluate other researchers' data science work, whether it's our colleagues, whether it's the news, whether it's something we found on social media. People are going to put data science research in front of us, and it's up to us to decide, is that a reliable study? And we don't get to say, I just don't like the conclusion, therefore I don't like it. Of course. And one of the other big themes that I always emphasize to my students in this course, and that I'll emphasize in this version, is how to keep learning and generating discoveries after this class is over. As I said, this is very much an intro to programming, so we'll give you we'll give you some skills for working with Python, but this is by no means a substitute for a full programming course. We'll give you some of the foundations of statistical thinking that will help you start really making the most of machine learning, but this is by no means a substitute for stats. And so as I go, I'll point out areas that you might go to learn more, other resources, and most importantly, in my view, I really do want to equip you not just to say, oh, I can do a few things, but to really go out there and take a data set, whether it's something you find online, something you collect yourself, something you've got maybe at work, and do really interesting, cool things with it. I believe incredibly strongly, and I was going to say this is the end of my soapbox, but this whole course is my soapbox, but this is the end of the soapbox for now. I believe incredibly strongly that the lowest hanging fruit for discovery among humans right now is taking the skills and techniques that are being developed in data science that are incredibly powerful, exciting, awesome, innovate, all this stuff, and combining it with areas that have not yet been touched by data science, or questions that we haven't really applied data science to. That's not the only way we can make progress, but there's so many interesting, complicated things out there in the world. My own bias is towards social issues. There's so much out there that we don't know and don't understand that we could be applying data science to. And so my hope is to empower all of you to start filling those gaps and making discoveries. We're going to save humanity so we don't have to live on a spaceship like where I am. With that said, a warm welcome, and let's dive in.